Today, we are going to answer an important question. Once a DNA sequence is stored as a string, can we change it? Imagine you typed a DNA sequence and later realize that the very first nucleotide is wrong. Instead of A, it should have been G. It feels like we should simply replace that one character. But can Python actually do that? Let's try to connect this with what we already know. Earlier we learned that DNA underscore sequence 0 gives us the first character of the string. And since we can access it, maybe we can also replace it. Does that sound reasonable? Before running any code, let's make a prediction. Will Python allow us to replace the first base, or will something unexpected happen? We first create a DNA sequence and then we try to assign a new value to the first position using indexing. This looks very similar to changing an item inside a list. Let's see what Python thinks. Python immediately raises an error. It refuses to replace the character, and this tells us something important about strings. Strings have a special property. After a string is created, its individual characters cannot be modified. And in programming, we say that strings are immutable. Think of a printed DNA sequence on paper. You can't magically change one printed letter. Instead, you create a new corrected copy. Python treats string in a very similar way. If changing the existing string isn't allowed, then how do programmers correct DNA sequences? There must be another approach. Instead of modifying the old string, Python encourages us to build a completely new string containing the corrected sequence. And here we create a new string. We start with the corrected base and then join it with everything from index 1 onwards using slicing. And the result is stored in a brand new variable called corrected underscore sequence. And the new sequence is exactly what we wanted, GTGC. Notice something very important. We now have two separate strings. One is the original sequence and the other is the corrected version. Now let's ask Python to show us the original sequence again. It is still ATGC. The original string never changed. We simply created another string with different contents. This idea appears often in bioinformatics. During quality control, trimming, or sequence correction, we typically generate new sequences instead of modifying the original sequence directly. Now let's summarize. Strings cannot be modified after they are created. And if you need a different sequence, create a new string. And this property of strings is called immutability.